Okay, so looking here at number 4 first, it says, it ties back in with number 3, right? So number 3 said the heights of 8 professional basketball players are here. Calculate the mean and the standard deviation. So if you did that one correctly, the mean should have been 192.5. The standard deviation was 2.5. So it says Bill's height when converted to a z-score is +1. So that means he is 1 standard deviation above the mean. So if the mean was 192.5, and then he's 1 standard deviation above that, which is 2.5, it would just be 192.5 plus 2.5, so he would be 195 centimeters, and that would be Bill's height. Okay, that's number 4. Number 7, 8, 9, and 10 all tie back to this image that you've probably seen before, which is like standard deviation with percentiles right here, where everything's kind of equally distributed. Notice that like there's 1 standard deviation, there's 2 standard deviations, there's 3 standard deviations, right? So if we look at the number 7, it says what percent of the scores lie within 1 standard deviation. So that's 68.3. 2 standard deviations was the 95.5, and 3 standard deviations is the 99.7. That ties back to just the normal distribution stuff. It's just using a z-score to describe it. Okay, and then number 8 says on a normal IQ test, the distribution of scores is normal with a mean of 100, a standard deviation of 12. What percent of scores lie between 76 and 124? Okay, you normally would have to use a z-score table. You'd have to convert these two values to a z-score and look at the two percentages. But this one's easier because 124 is exactly 2 standard deviations above the mean. 76 is exactly 2 standard deviations below the mean. So it's everything that's within 2 standard deviations of the mean, or 2 z-scores of the mean. And so if we look back here, if we're within 2 standard deviations below and 2 standard deviations above, we're at 95.5% of the scores. So 95.5% of all students should score between 76 and 124. Number 9, it says what range of scores would account for 99.7% of people? Well, 99.7 is just one more standard deviation, right? So you just go 12 lower on your scores and 12 higher on your scores, and that would be 99.7. And then at the end of the semester math test, the mean result was 62. The standard deviation is 12. What percent of results would lie above 86? So 86 is 2 standard deviations above the mean, right? Mean was 62, 12% was my standard deviation. So if I look at 2 standard deviations above the mean, I fall right here. And so what percent of scores are going to fall above that score? Well, it is like 2.13, and then you have like this little part out here, which is like 0.015 or 0.15. So it'd be like 2.48 would be the total number of scores that fall above that score. Okay, you will eventually need to use the z-score table for some of these when it's not exactly on a standard deviation, but for these, because they fall exactly on your standard deviations, you can use these percentages that you're given. And then when you get to some of the problems that are like random numbers that are not exactly 1 standard deviation or not exactly 1 z-score, because z-scores and standard deviation are kind of similar, then you will need to actually use the z-score table to look up the percentages and calculate it that way. So if you have any more questions, let me know. Hopefully this helps a little bit.